Let's evaluate the integral of 1 over e to the x plus 1. In my opinion, this is not the most straightforward integral, and it's not one that you could determine what method of integration to do immediately, but maybe you might have some idea. You would want to do a u substitution, and that would be the correct way of thinking, but there's also several ways that you could do this substitution. I think the most straightforward method would be to set the entire denominator as u. So that's what I'm going to do. And then the derivative of this would be e to the x dx. Now here's where we run into some issue. The fact that my du term is not something that I could easily integrate into. So it's like my dx is 1 over e to the x du. And that doesn't match up with what I have in here. So if I were to rewrite this integral in terms of u, I'd have 1 over u times 1 over e to the x du. So what do I do about this e to the x? Well, I go back to my definition of u, and I define e to the x in terms of u. So e to the x is equal to u minus 1. And if I substitute that back into this integral, I would have 1 over u times 1 over u minus 1 du. Now that problem is solved. Integrating this part is also not that easy. You could do partial fraction decomposition, but what I think is easier is doing another substitution. But it's not the most obvious. So if I simplify this by distributing the terms in the denominator, I have 1 over u squared minus u du. And now I can factor out the u squared in the denominator, so I have 1 over u squared times 1 minus 1 over u du. Now the reason I did this, the reason I factored that u squared, is so I can do the other substitution. This new substitution, let's define a new variable t. I'm going to take that 1 minus 1 over u as my substitution, because the derivative is 1 over u squared du, which is exactly what I have over here. And so that works out really nice. So now if I do my t substitution, I get 1 over t dt, which is very nice and simple, and I can immediately integrate this. It's equal to the natural log of t plus c. And with that, we're done with the integration part. But we just have to go back in and substitute everything so that we go back to our original variable, which was in terms of x. So substituting t, we get 1 minus 1 over u. And then when we go back to what we defined in u, we said u is equal to e to the x plus 1. So this is equal to the natural log of 1 minus 1 over e to the x plus 1. That's it.